Hello friends, welcome back to C-Level Physics. My name is Srinivas. In this lecture, I would like to solve some numericals based on equations of motion. Okay, let us see one by one. First question, here a particle moves rectilinearly with the deceleration whose magnitude depends on velocity v of particle as a equal to k root v. See, this is the magnitude of deceleration. Means particle is under retardation whose magnitude is given by a equal to k root v, where k is some positive constant. If you have t equal to 0, the velocity of particle is v0. Means at t equal to 0, velocity means initial velocity. So initial velocity is v0. Find the total distance traveled and total time of motion for the particle. So you are given the magnitude of a deceleration, that is a equal to k root v, and you are asked to determine the total distance covered before coming to rest and the total time of journey. Okay. Now we know that acceleration in the sense there is some increase in speed at every instant, but deceleration in the sense there is decrease in speed at every instant, and finally it comes to rest also at some instant. Okay. So you are given the magnitude of deceleration. Means if I take acceleration a equal to minus k root v. Why? Because here this is the magnitude of acceleration, deceleration. I am taking acceleration. So acceleration in the sense here negative sign. Why? Because its speed decreasing from v0 to 0. Right? So here first we need to find total distance. As we need to find total distance, now take acceleration in the form of a equal to v into dv by ds. Why? Because acceleration in the sense we have relations a equal to either dv by dt, that also equal to d square s by dt square, that also equal to v into dv by ds. v into dv by ds. This is what chain rule, right? This is what the second derivative of displacement with respect to time is acceleration. Otherwise, the rate of change of velocity also acceleration. So here we need to find displacement. That's why take this formula into consideration. Right? So replace v equal to dv by ds, which is equal to minus k into root v. Now carry this root v onto LHS, that is v by root v, v by root v into dv equal to minus k into ds. What is the significance here? In every distance there is the decrease in the velocity is dv. See here negative sign is there, that means to say that on covering every ds the decrease in velocity is dv. So ultimately before coming to rest it covers some distance and final velocity becomes 0. Right? So to get total distance covered, we have to integrate the expression on both sides. That is integral v by root v, means root v in the sense v power of, I am taking to numerator 1 minus of, means v power of into dv. So v power 1 by v power of, that is I am taking to numerator v power of into dv. Now what is RHS minus k into integral ds, right? So what is the initial displacement? 0. Now what is the initial velocity at t equal to 0? What is the initial velocity? v0. So v0, right? Now what is the total displacement covered before coming to rest? Means s. So I am covering s. What about the velocity here? 0, right? Initial velocity v0. As particle is under retardation, finally it comes to rest. So what is the upper limit for velocity here? 0. So here what is the lower limit for displacement? 0. Upper limit s. Total displacement s. Right? Now I am taking v power of into dv. We know that integral x power n dx equal to x power n dx equal to x power n plus 1 by n plus 1. So therefore here also v power, x means here v, n means here of, therefore x power n plus 1 means v power of plus 1 by v power of plus 1 half plus 1. What are the limits here? V0 to 0. So this is the solution for the integral v power half into dv, that is v power half plus 1 by half plus 1, right? That equal to minus k into integral ds means, yes, integral ds means summation of all ds values, that is you will get total displacement s. Now what is the limits here? 0 to s, 0 to s, right? Now here 1 plus 2 plus 1 means 3 by 2. I am taking the numerator, that is 2 by 3 into v power 3 by 2. V power 3 by 2. V power 3 by 2. Limits. What about limits here? V0 to 0. V0 to 0. V0 to 0. That is equal to minus k into. Here upper limit is, lower limit 0. That is upper limit minus lower limit. Upper limit minus lower limit, that is s minus 0. So therefore 2 by 3 into, what is the upper limit here? 0. So instead of v, take 0, 0 power 3 by 2 minus lower limit v0. So v0 power 3 by 2 equal to minus k into s. So here 0 power 3 by 2 means 0, that is 2 by 0. So 0 minus v power 3 by 2 means minus 2 by 3 v0 power 3 by 2. That equal to minus ks, minus ks. Okay, so minus cancel, we left with minus cancel, s equal to, what is s? S equal to 2 v0 power 3 by 2 whole divided by 3 into k. So this is what total distance covered before coming to rest. Total distance covered by the particle before coming to rest. Now, what is the next question here? The total time of motion for the particle. So take another expression, a equal to, this is what number 1. Number 2, a equal to minus k into root v. Am I right? So we need to find time. So therefore take that expression, a equal to dv by dt, rate of change of velocity, that is dv by dt. dv by dt equal to minus k into root v. Right? What is the significance here? dv by dt. dv by dt equal to minus k into root v. Now, if you want to get the total time taken to come to rest, what shall we do means we have to integrate. Why? Because in every dt the decrease in velocity is dv. How will you know means, see this negative sign saying that the decrease in velocity is dv for every dt, right? So if you want to get total time taken to come to rest, take integration on both sides, that is integral dv divided by, take this root v onto LHS, integral dv by root v equal to minus k into dt, right? Minus k is constant, integral dt. See once again, minus, that is dv by root v equal to minus k into integral dt, right? What are the limits here? Initial instant 0. At t equal to 0, what is the velocity? v0. Okay. Now what is the time taken to come to rest? Let it be t. So upper limit t. At t, what is the final velocity? 0. Why? Because body comes to rest. Right. Now root v means v power half. I am taking the numerator v power minus half. V power minus half into dv. So integral v0 to 0 equal to minus k into integral 0 to t dt. Alright. Now integral x power n dx means x power n plus 1 by n plus 1. X means v. So v power n plus 1. N means minus 1 by 2. V power n plus 1 by n plus 1. N plus 1. Limits v0 to 0. That is equal to minus k into integral dt. Summation of all dt values. What will you get? That is t. Total time t. So solution t. Limits 0 to t. 0 to t. Now minus half plus 1 means half. 1 by half means 2. So 2 into v power minus half plus 1 means v power half. That is 2 into v power half. Limits v0 to 0. That equal to minus k into upper limit. Otherwise k into t 0 to t. Next step, that is 2 into. Now what is upper limit? 0. So instead of v, take 0. That is 0 power half means 0 minus take v0 instead of v. That is v0 power half. That is minus k into t minus 0. Upper limit minus lower limit. T minus 0. Now here minus is there. Here also minus is there. Minus minus cancel here. We left with the 2. v0 power half means root v0. Root v0 equal to k into t. What about t? T equal to time taken to come to rest by the particle. T equal to 2 root v0 by 2 root v0 by k. 2 root v0 by k. This is what total time taken to come to rest. Okay. Next numerical here. Here car race. In a car race, car A takes t seconds less than car B at the finish and passes the finishing point with a velocity v meter per second more than that car B. Assuming that cars start from rest and travel with constant accelerations a1 and a2 respectively, v is equal to what? Here we have 4 options. See here, car A, car B. So these are initial positions of the cars. Alright. So both are ready to take run. So both starts from rest means initial velocity 0. So for B also is 0. For A also initial velocity 0. Alright. So this is the direction of car. What is the acceleration of car A and B? For car A, let be A1 from data. For car B, it is A2. Right. So this is the final destiny point for both A and B. Right. For both A and B, this is the final destiny point. Right. Now from data, car A takes t seconds less than car B and acquires v meter per second more velocity than car B. So here at the end, what is the velocity of car A? Let be v1. What is the velocity of car B? Let be v2. Now what is v1 and v2 here? From data, v1 equal to v2 plus v. Why? Because car A gains excess velocity by an amount v than car B and takes t seconds less also. Now what is the time taken by car A to reach destiny? Let be t1. What is the time taken by car B to take entire destiny, that is to reach destiny, that is t2, right? Now what is the relation between t1 and t2? t1 equal to t2 minus t. Why? Because car A takes t seconds less than that of car B, right? t1 equal to t2 minus t, right? So from data, v equal to v1 minus v2, and t equal to t2 minus t1, right? Of course, both A and B covers equal distances before reaching destiny. Now what is the distance covered by A? Let be s1. What is the distance covered by B? Let be s2. But s1 equal to s2. Alright? Okay. Now what are the accelerations here? For A it is a1, for B it is a2. So a1 equal to, from definition, what is acceleration? Acceleration equal to change in velocity by time. Change in velocity for A, initial velocity 0, final velocity v1. So v1 minus 0 by t1, that is v1 by t1. For a2, acceleration of car B, that is a2 equal to final velocity minus initial velocity by time, that is v2 minus 0 by t2, that is v2 by t2. Alright. Now both covering equal distances. Am I right? For example, s1 equal to, what is s1? The distance, total distance covered by A. before reaching destiny. That is S1 equal ut plus half x square. Ut plus ut1 plus half a1 t1 square. What divide u? u1 equal to 0 here, u2 also 0. So u1 0. I'm taking 0. S1 equal to half a1 t1 square. Otherwise, we can take one more relation also. What is that relation? That is average velocity into time. Displacement equal to average velocity into time. Otherwise, distance equal to average velocity into time, provided acceleration is constant. So S1 equal to 0 plus initial velocity plus final velocity by 2 into t. That is 0 plus v2 by 2 into time. What about time t2? That is S1 equal to v2 t2 by 2. Similarly, S2 S1 displacement is covered. Suppose displacement covered by A, S1 equal to average velocity in time. Average 0 plus V1 by T1. So 0 plus V1 by 2 into T1. That is S1 equal to V1 by 2 into T1. Similarly, displacement covered by car B, S2 equal to average velocity 0 plus V2 by T2. 2 into T2. 0 plus V2 by 2. That is average velocity into time T2. That is S2 equal to V2 T2 by 2. But S1 equal S2. Why? Because destiny is same for both. Initial positions also same, final positions also same. Therefore, S1 equal to S2. So S1 equal to S2. S1 equal to S2. What about S1 V1 to V1 T1 by 2 equal to S2 means V2 T2 by 2. V2 T2 by 2. So 2 to cancel. We left with V1 by V2 equal to T2 by T1. V1 by V2 equal to T2 by T1, right? Now take minus 1 on both sides. That is V1 by V2 minus 1 equal T2 by T1 minus 1. Why? Because we have V1 minus V2 equal to V. T2 minus T1 equal to T. T2 minus T1 equal to T. Alright. Now take LCM V1 minus V2 by V2 equal T2 minus T1 by T1. V1 minus V2 means V. That is excess velocity of car A and car B. That is V by V2. V by V2 equal T2 minus T1 means T seconds. Car A takes T seconds less than that of car B on reaching destiny. So T2 minus T1 equal T by T1 by T1. Right? That is V2 by T1 equal V by T. So V2 by T1 equal to V2 by T1 equal to V2 by T1 equal to V by T. Suppose number 2. This is what number 1. Number 1. Alright? So 1 implies, I'm taking 1 implies, here see, V1 by T2 equal V2 by T1. Am I right? 1 implies, so 1 implies, see here, V1 by T2, otherwise V2 by T1, V2 by T1, V2 by T1 equal V1 by T2, V1 by T2, V2 by T1 equal V1 by T2. Again V2 by T1 means V by T, which is equal to V by T. So from 1 and 2 implies, from 1 and 2 implies, from 1 and 2 implies, see here 1 implies V2 by T1 equal V1 by T2. Again V2 by T1 means V by T. So all the three are same. All the three are same. Of course, if T2 is there somewhere here, V2 by T2 would be A2. If T1 is there somewhere here, V1 by T1 would be A1. But here T1 is there, here T2 is there. If I take V by 2 into V by T, that is V by 2 into V by T into V by T equal to V by T into V by T. That is equal to V by T means take this formula V1 by T2. Again V by T means take this formula, that is V2 by T1. Now see here V1 by same can be written as here V by T whole square equal to, see here V1 by T1, here V2 by T2, right? They are grouped into these forms, that is V1 by T1 multiplied by V2 by T2. V2 by T2. Why? Because here V2 by T1 is there, but T2 is not there. If there is T2, we can write it as A2. Here V1 by T2 is there, but T1 is not there. If it is there, we can write it as A1. So to take that forms, I am taking product of V by T and V by T. So V by T into V by T equal to, once write this one more time, write this one. So therefore V by T whole square equal to V1 by T1 into V2 by T2. That is V by T whole square equal to, what about V1 by T1? Here V1 by T1 equal to A1. That is A1. Here what about V2 by T2? That equal to A2, acceleration of car B. Alright. That is V by T equal root A1 A2. V by T equal to root over A1 A2. That is V, that is excess velocity of car A, then car B is given by V equal to T root A1 A2. This is the ultimate answer. V equal to T into root A1 A2. That is what? T into root A1 A2. Option C is the correct answer. Okay, right? Coming to next numerical here. Here we have one equilateral triangle of side A. See, at the corners of equilateral triangle of side A, we have three particles, say A, B and C, are located as shown. See, at all the three vertices, there are three particles A, B and C located, right? Now at t equal 0, all particles start moving at uniform speed v. So at t equal 0, they start moving with velocity v, right? Constant velocity v, such that always velocity of A is heading towards B, B is heading towards C, C is heading towards A. See, A is heading towards B, but at the same time B is heading towards C, at the same time C also heading towards A. Alright. Now find the time after which these particles will meet. These particles will meet, right? Now let us see. This is what initial velocity of initial direction of motion of A. See, this is the initial direction of motion of A. This is what initial direction of motion of B. Like that. So this is what initial direction of motion of A. This is what initial direction of motion of B. But the direction of motion of A is changing by itself according to the direction of motion of B. What is the direction of motion of B here? Initially along this way, but according to C, the direction of motion of B also adjusting itself. At the same time, what is the direction of initial direction of motion of C here? This is the initial direction of motion of C. But according to A, the direction of motion of C also adjusting by itself. Am I right? Now see, this is what initial direction of motion of A, this is what initial direction of B, right? Now B changing its direction with respect to C, like that. According to which the direction of motion of A also changing, like initially like that, but this is also initially like that, but B changing its direction with respect to C, like that. At the same time, A also changing its direction with respect to B, like that. See, once again, these are initial directions. Later on, gradually what happens? Turns like that. See, one more time. This is the initial direction of A, this is the initial direction of B. Now they are changing their direction of motions with respect to time, like that. Like that. Means they meet somewhere here, right? They meet somewhere here, like that. So These are the directional motions of A and B, right? At the same time, what about the directional motion of C here? So initially A is moving like that. Initially C also moving like that. But later on, what happens? What happens is, suppose, what happens? Now A change its direction like that. So C also will change its direction according to A. So A turns like that, C also turns like that. So with respect to A, C also change its direction. Okay, such that always heading towards A. So this would be the direction of motion of C. So this is the path followed by A, this is the path followed by B, this is the path followed by C. See, A heading towards B, always. B heading towards C, always. C also heading towards A, always. So these would be the paths followed by particles, all the three particles. So ultimately they will meet at centroid. They will meet at centroid. Now see, what is the vertex angle? At each vertex 60 degrees, 60 degrees, 60 degrees. Why? Because that is what? Equilateral triangle. Equilateral triangle. Right? Equilateral triangle. Now the question is, after what time all together will meet? So all together will meet after some time. What is that time taken to meet at centroid? Okay. Now let us see. Let us see. Suppose I am I join this centroid onto this side line. Take one normal from this centroid onto side AB. Right. Now join A with centroid like that. Directly. Right. You will have one right angle triangle. Right. You will have one right angle triangle. What is that right angle triangle here? This is what right angle triangle. This is what right angle triangle. Okay. Now what is the side A? Here also A. This is what A by 2. A by 2. This is also A by 2. Now what is the total angle here? 60. Now what about half angle here? Half angle 30 degrees. 30 degrees. Now this is what? Side A by 2. So A by 2. Right. Now what is the displacement covered by the particle? Each particle on reaching centroid when they meet means, as far as A is concerned, this is the initial position. This is the final position. Centroid, let it be O. Let it be O. Let it be A here for particle A. Right? Now, see this dashed line. This is the displacement covered by A. Of course, this would be the displacement covered by C. The line segment joining from initial position to final position. Now, coming to B, this would be the displacement covered by B. Right? So, a line segment taking from initial position to final position. So, this is what displacement for A, this is what displacement for B, this is what displacement for C. So, all are having same magnitude of displacements. So, this is what, as far as this triangle is concerned, this hypotenuse is the displacement S. Right? Now, what is that S here? S equal to cos 30. Cos 30 equal to adjacent side by A by 2 by hypotenuse S. Now, S equal to A by 2 by cos 30. Cos 30. This is what displacement covered by A. Of course, for B also same only. For C also same only. But directions only different. This is the direction of displacement for A. This is the direction of displacement for B. This is the direction of displacement for C, like that. So we have displacement. Now coming to velocities. What is the initial direction of motion of A? Horizontal, from A to B. This is the initial direction of motion of A. So take one more right angle triangle here. One more right angle triangle. For this half angle. For this half angle. This is what? Velocity V. This is what? Initial velocity of A. That is heading towards B initially. So V. Now this is what displacement. In the direction of displacement, what about component of velocity of A here? That is, I am taking like that. Along the displacement, what about the component of velocity? What about the component of velocity? See here, this is what? 30 degrees. If it is V, what about the component along this way? V cos 30. V cos 30. So this is what V cos 30. Alright. So along the displacement, as far as A is concerned, I am taking A into consideration. So this is the displacement of A. In the same direction, V cos 30 is the velocity of A. Of course, V is the initial velocity towards B, but its component is V cos 30 along displacement. See, these two parallel to each other. Now displacement equal to velocity into time. That's all. Displacement equal to velocity V cos 30 into time. Right. Now what about displacement A by 2 by cos 30? So A by 2 by cos 30 equal to V cos 30 into T. That is A by 2 into cos A by 2 into V. We also carry this V to LHS. So 2 comes to denominator, A by 2 into V. Cos 30 also carry this cos 30 to this side, that is cos 30 into cos 30, cos 30 whole square, cos 30 whole square, cos 30 whole square, that is equal to time. Now what about cos 30 root 3 by 2? That is A by 2 into root 3 by 2 whole square equal to T. Now see here, 2 square means 4, 4 goes to numerator, 4 by 2 means 2, 2A, that is 2A, 2 square means 4 goes to numerator, 4 by 2, 2A by root 3 1 square means 3V, that is equal to T. Okay, this is what? The time taken by the all A, B and C to meet at centroid. Okay. Coming to next numerical here. Here, a train of length 350 meters starts from rest at uniform acceleration 0.03 meter per second square. At time t equal to 30 seconds, its headlight is switched on, right? Which is to be taken as event 1. And at t equal 90 seconds, its tail light is switched on, which is to be taken as event 2. Alright? Find the distance between these events with respect to ground frame and train frame. So here we have one train, right? It has two lights. One is headlight somewhere here in front of the engine. One more is tail light, TL. TL means tail light. Laid behind the last compartment. Okay, right? Now what is the length of the train? 350 meters. Now it starts from rest and moves with acceleration 0.03 meter per second square. Right? Now after 30 seconds, headlight is switched on. Headlight is switched on. Of course, this is the concerned instant here. Of course, train is moving along straight line with constant acceleration. So along straight line, but I drew the diagrams right on the bottom to make you better understand. Okay, this is the instant at t equal 30 seconds at which headlight is switched on. Headlight is on. See here, headlight is on. Right? After 90 seconds, this would be the position of the train, for example. Of course, all the three diagrams, one after the one along straight line, but I drew below, right on the bottom to make you better understand. Am I right? Now see, at t equal to 0, initial velocity of the train is 0. Now I am taking this position be the origin, that is x equal to 0. Means somewhere here I have taken x equal to 0 means origin. So with respect to origin, what is the coordinate of headlight at t equal to 0 means 350 meters. See, this headlight is at a distance of length of the train at t equal to 0. Am I right? L equal 350 meters. Okay. Now after 30 seconds, the diagram would be drawn somewhere here, but I drew down on the right here to make you better understand. Okay, right? So this would be the position of the train. So here it is headlight at t equal to 0. This is the position of headlight at t equal to 0. Now this is the position of the headlight at t equal to 30 seconds, at which headlight is on. See, this is the headlight from which rays are coming. Am I right? Light is coming out. So this is the position of the headlight. Now what is the distance covered by the headlight here from here to there? This is the distance covered by the headlight S1. See, this is the initial position of the headlight at t equal to 0. This is the final position of the headlight at t equal to 30 seconds at which headlight is on. Right? Now what is S1? S1 equal to ut plus half AT square. What about U0? Why? Because this is starts from rest. Therefore S1 equal to half a T1 square. Half a T1 square. That is, since U equal to 0, that is half into, what about A? Acceleration means 0.03 into T1 square. T1 means what? 30 seconds. That is 30 seconds. 30 seconds whole square. That is half into 0.03 into 900. So 9 into 100, 100 into 0.03 is 3. 3 into 9, 27. 27 by 2. That is 13.5 meters. So this is the distance covered by the headlight when it was on. Am I right? Now what is the position coordinate of headlight with respect to origin? See, this is the origin. This is the origin. With respect to this origin, what would be the position coordinate of headlight means 350 meters. See, length of the train 350 meters plus S1. So x1 equal to position coordinate of headlight at which event 1 occurs. Event 1 occurs means what is the event 1? To glow headlight. Am I right? So by that time, what is the position of the headlight here means that is 350 plus S1. So x1, that is position coordinate of event 1, right, at which headlight glows. That is x1 equal to length of the train plus S1. Length of the train plus S1. That is, what about length of the train? 350 meters plus S1 means 13.5 meters. So that is 363.5 meters. This is the position coordinate of event 1 by that time at which headlight is on. Am I right? Now coming to next event. What is the next event? After 90 seconds from the beginning itself, after 90 seconds, what is the event 2? That is tail light is switched on. See, this is the tail light. After 90 seconds, tail light is switched on. See, tail light also switched on. So light is coming out like that. Right? In fact, all the 3 diagrams is along straight line only, but to make you better understand, I drew one after the other like that. Okay? Now, see, what is the distance covered by the tail light in that 90 seconds? In that 90 seconds, see, this is the position of the tail light. Tail light at t equal to 0, this is the position of the tail light. At t equal to 90 seconds, this is the position of the tail light at which event 2 occurs. That is, it was switched on. Right? This is what distance covered by the tail light along with the train when it was on condition. Right? That is, this is what S2. So from here to there, see, this is the x equal to 0. This is the position coordinate of tail light when it was on condition. So this is what S2. This is what S2. What about S2? S2 equal to half AT square. I am writing somewhere here. S2 equal to half AT square. S2 equal to half A T2 square. That is half into A means 0.03 into T2 square. What is T2? T2 means 90 seconds. Right? 90 whole square. 90 whole square. That is half into 0.03 into 90 into 90, that is 8100. Right? Now 2 zeros, that is 100 into 0.03 means 3. 3 into 81. 3. 243 by 2. 243 by, so S2 equal to 1 to 1.5 meters. So what is the distance covered by the tail light in 90 seconds when it was on condition with respect to train? That is 121.5 meters. 121.5 meters. Am I right? This is the distance covered by the tail light. This is the distance covered by the tail light when it was on condition. Right? Now the question is, find the distance between these two events with respect to ground frame. With respect to ground frame. With respect to ground. With respect to ground. What is the distance between these two events? What are the events? To glow, headlight first and tail light next. These two events occurs one by one at 30 seconds and at 90 seconds. What is the distance between or separation between these two events with respect to ground frame? With respect to ground frame means the difference in position coordinates. Right? See, this is the position of headlight when it was on condition. Now what is the position coordinate means? From here to there. From here to there means 350, that is the length of the train plus S1. What is that answer? 13.5. 13.5. So x1 equal to 363.5. So this is what x1. This is what x2. The position coordinate of tail light with respect to ground when it was on condition. Of course, which is equal to x2 also. Right? So this is also equal to x2. Now with respect to ground, what is the separation between these two instants? Means x1 minus x2 gives this separation. So delta, that is separation between these two instants or these two events, is equal to x1 minus x2. That is, what about x1? Delta equal to x1 means 363.5. 363.5 minus x2 means what? 121.5. 121.5. 121.5. That equal to 5 minus 5, 0. 3 minus 1, 2. 6 minus 2, 4. 3 minus 1, 2. That is 242.0. That is 242 meters. 242 meters. This is what the separation between these two events with respect to ground frame. Am I right? The difference in position coordinates of headlight and tail light when both comes into on condition. Now coming to one more question. What is that? What is the separation between these two events with respect to train frame? With respect to train frame. So in that, suppose here first event occurs at t equal 30 seconds. Second event occurs at t equal 90 seconds. What is the separation between? What is the interval between? Time interval between these two events means 60 seconds. In 60 seconds, the distance traveled by headlight is equal to the distance traveled by tail light. Okay, along with the train. So therefore, both are separated by a distance which is equal to length of the train only. See, headlight is laid somewhere here, tail light is laid somewhere here, behind the last compartment, here in front of the engine. So these two are separated by distance 350 meters. So in 60 seconds interval, time interval, the distance traveled by headlight, okay, is equal to the distance traveled by tail light. But both are separated by distance equal to length of the train. So naturally, with respect to train frame, the separation between two events is given by length of the train. So with respect to train, the separation between events delta is equal to length of the train, that is 350 meters. 350 meters. Okay, so that's about answers, right? Finally, one more numerical. What is that? See here, a railway track runs parallel to a road until A turn brings the road to a railway crossing. A cyclist rides along the road every day at a constant speed of 20 km/h. He normally meets the train that travels in the same direction at the crossing. One day he was late by 25 minutes and met the train 10 kilometers before the railway crossing. Find the speed of the train. See, this is what railway track, this is what road, both are parallel to each other, both meet at railway crossing somewhere, level crossing, right? See, this is the initial position of the train that is fixed for every day. This is the starting position of the cyclist. This is also fixed for every day. What is the normal speed of the cyclist every day? That is 20 km/h. That is fixed. So no deviation at all. What is the constant speed of the train? Let it be Vt. That is to be known. That is to be found later. So Vt is unknown. This is also fixed one. This is also fixed one. The velocity of cyclist also fixed. Velocity of the train also fixed. Right? Their starting positions also fixed. Okay. Now what is the distance of the train from the railway crossing? Let it be x. Let it be x. Let x be the distance of the train from the railway crossing. Let y be the distance of the cyclist from the railway crossing, from their initial positions. Right? So these distances to be covered by both the train and cyclist every day. Right? With their constant speeds from their initial positions, both meet at railway crossing every day. Right? With the speed of cyclist to 20 km/h, with the unknown speed of Vt for the train. Right? Now, the time taken to cover a distance of x by the train is equal to the time taken to cover a distance of y by the cyclist. Right? When meeting at railway crossing. So T1 equal to T2. T1 equal to T2. T means what? X equal Vt. T equal x by V. So x by Vt equal to T2 means y by speed of the cyclist, that is 20 km/h. Right? From which Vt equal to say 20 x by y. 20 x by y. This is what number 1. This is what number 1. This is what number 2. Am I right? Right. Now, one day the cyclist, he was late by 25 minutes. Particularly on that day, he met the train not at the railway crossing, but met at a distance of 10 km before the railway crossing. So what is this distance? 10 kilometers. 10 kilometers. So in that timeline, definitely train advances through some distance. See, this is what distance covered by the train. Right? So S equal to Vt. X train, that equal to V train into time. So on that day when he was late by 25 minutes, in that timeline, in that 25 minutes, definitely train advances through this much of distance. What is that distance? Xt equal to Vt into t. That is Vt into t means 25 minutes. 25 minutes in the sense, minute means into 1 by 60 hour. 25 by 60 means 5 by 12 hour. 5 by 12 hour. Why? Because the speed of cyclist is given in kilometer per hour. Somewhere here. Kilometer per hour. So time also is to be taken in hours one. So when he was late by 25 minutes, the distance covered by the train, when he starts his motion, is given by xt equal to Vt into t, that is Vt into 5 by 12 hour. So this is the initial position of the train. This is the initial position of the cyclist on that day when he was late by 25 minutes. Right? So On that day, he met the train somewhere here, at a distance 10 kilometer before the railway crossing. So on that day, in the time interval, this is the distance covered by the train, that is ST. This is the distance covered by the cyclist, XC. So the time taken by the cyclist in covering a distance of XC is equal to the time taken by the train in covering a distance ST. Am I right? So T1 equal to T2 once again. That is T1 equal to T2 once again. Right? T1 equal to T2. When he was late by 25 minutes. That is 25 minutes means 5 by 12 hour. 5 by 12 hour. When he was late by 25 minutes, that is 5 by hour. The distance covered by the time taken to cover the distance of ST by train is equal to the time taken to cover a distance of XC. See this word from here to there XC. From here to there XC. Distance covered by cyclist. So time taken in covering XC and HT by respect to cyclist and train is same. That is T cyclist equal to T train. What is time? Once again, time equal to distance by speed. Distance by speed. What is the distance covered by cyclist here? That is y minus 10. See this is what y. Usual distance y minus 10 km, that equal x. So y minus 10 by speed. Speed means 20 km. Right? That equal to time taken by the train in covering a distance of ST. What is ST? See, this is what ST from here to there. From here to there. ST means, how to get ST means x minus 10 minus this amount. What is this amount? Vt into 5 by 12. So once again, ST means x minus 10 minus this one. This one means Vt into 5 by 12. So distance by speed. T means once again distance by speed. Distance means this much only. That is x minus 10 minus this one. X minus 10 minus this one. You will get this amount. This is the distance covered by the train. On that day when he was late by 25 minutes. Right? Before meeting both. So what is this amount? That is Vt into 5 by 12. Vt into 5 by 12. V train into 5 by 12. Whole divided by speed. Speed means what? Unknown. Vt. That only we need to find. What is the speed of train? That is the question. Right? Now see, three unknowns are there. X is unknown, Y is unknown, Vt also unknown. Right? So here, eliminate Vt by writing implies Vt equal to 1 implies Vt means 20x by y. Vt means 20x by y. Right? So substitute 2, that is y minus 10 by 20 equal to x minus 10 minus Vt means what? 20x by y. 20x by y into 5 by 12 whole divided by Vt. Vt means 20x by y. 20x by y. So 20 cancel. Right? That is y minus 10 equal to 1 by x by y means y by x whole into, see LCM 12y. 12y into x, that is 12xy minus 12y into 10, that is 120y minus 20 into 5, that is 100 into x. 100 into x whole divided by 12y. Am I right? So again y gets cancelled. Right? We left with here 12 into x 12x into y, that is 12xy, minus 12x into 10, that is 120x, is equal to 12xy minus 120y minus 100x. Okay, 12xy cancel, right? Here minus 100x is there. Carry this minus 100x onto LHS, that is plus 100x minus 120x minus 20x equal to minus 120y. That is minus minus cancel. We left with x equal to 6y. Number 3. X equal to 6y. Now replace x by writing 6y in second expression to get velocity of train. So 2 implies Vt equal to velocity of train equal to 20 by y into x. What is x? 6y into 6y. Since from 3, third expression. Since from 3. Okay. That is y cancel here. So we left with Vt equal 20 into 6, 120 meter per second. So this is what velocity of train, that is 120 meter per second. Right? That's how one can find velocity of train. Okay.